Okay, so welcome everybody. So I hope you can all hear me now. So thanks very much for joining this departmental talk series over the summer. So I thought I would talk a little bit about a topic we might be all concerned with, which is climate change, and then also a little bit about the research I've been doing on this topic in terms of experiments I've been doing on it. So can we cooperate to save the climate is the question of today's talk. And I want to start the talk very lightly with this little cartoon. So what does this little cartoon show us? So it's basically a long stretch of human history and the temperature that we've been encountering over all this time. So it starts 20,000 years before Christ's birth at -4 degrees centigrade relative to where we are now. So this is all we know, the ice age that came before people started basically living as hunters and gatherers and so on and so forth. So you can see that, you know, we started a little bit colder than we live today. And if you let a lot of time pass, and I cut out a little bit of this cartoon so you can look at the full cartoon at XKCD afterwards, is really nice. If you let a lot of time pass, then we get at 500, around 500. And you can see that this is basically a temperature of 0 relative to where we are now. And that has been going on then mainly for the period of history that we've been all you know, looking at in our history classes. So the Romans, the Egyptians, all of us, they lived basically in a pretty stable climate. And that continued through our nearer history for quite a long time. And you had a slow dip into, you know, colder temperatures around 1500. So that had to do with volcanic eruptions that basically, you know, reduced the sunlight that was coming through to the Earth. So you had what is called a little ice age here. And this comes up in storytelling where they talk about these long winters and so on and so forth. But other than that, this climate has been very stable. Up to a point that starts around 1850, 1900. And what we can see up from this point upwards is a rising trend in temperatures. And that has been slowly rising. And then in more recent years, it has been more rapidly rising. And at the moment, we are basically 1 degree centigrade warmer than we are used to. And now you can see these little dashed lines at the end. So these little dashed lines are basically what the future might look like, right? And you have different scenarios here, right? So you have one scenario where we try to stop this trend, and then we will settle at 1 degree warmer. So this is basically the climate that we have now, and all looks good. Then there's a slightly, you know, what they call the optimistic scenario here, where we let temperatures rise a little bit more, but then you can see that this trend again stabilizes, right? And the problem with these two scenarios is that this is not the current path we are on. The current path that we are on, and that is if we don't cut any more carbon emissions, might bring us into temperatures that are much warmer than what we are used to, right? And what I want to stress with this cartoon is simply, well, what is climate change doing to us as, you know, humankind or as a human species? Well, it brings us to a point that we've never experienced before. And that's sort of the dangerous bit of climate change, right? So it's just unprecedented in human history what is going on at the moment. We haven't lived as a species through a climatic condition like the one we are moving towards if we don't do anything about climate change. So why is this all a problem? So you can look at this a little bit more honestly, and there's an organization that does that, and that's the IPCC, right? The IPCC is the International Governmental Panel on Climate Change, and they do these reports regularly, and they have like summaries for policymakers so that policymakers get an idea of what is going on. So on the right side, you see basically a couple of diagrams, what has been going on in terms of emissions since the 1850s. And you can see that basically major greenhouse gas emissions have been rising. So this is true for CO2. So that basically happens if we, for example, burn coal. And this is also true for other greenhouse gases like methane. So methane is another powerful greenhouse gas that mainly comes from agriculture. The bottom graph here shows you even more how rapidly these emissions have been rising over the last 50 years, right? So if you look at this graph, you look at 1950, and then you can see quite a dramatic rise in greenhouse gases, which come basically from burning fossil fuels, from using cement in buildings, and then you have also emissions that come basically from the fact that we are reusing land. So we're basically cutting down forests and we're building agricultural land, and that contributes to greenhouse gases. And you can see it very nicely in this graph, which goes from 1750 to 1970. You had some cumulative emissions, and then if it goes from 1750 to 2011, this rise is much larger. So what's the effect of all of this? Well, that you can see on the left-hand side. On the left-hand side, you can see basically these graphs that suggest that burning these carbon emissions might have an effect on the climate, and that effect on the climate manifests itself in terms of temperatures. It might manifest itself in terms of sea levels, and it might manifest itself in changes in weather patterns more generally. So rain seasons and natural disasters, hurricanes, things like that might all change due to this change of carbon stocks in the atmosphere. So why is this problematic, right? So if you look at what the IPCC said in 2007, and this is already slightly dated, they have a very nice quote where they're talking about a change between 1.5 and 2.5 degrees centigrade. And many of you will be aware of this goal of, limiting temperature rises to 2 degrees or even 1.5 degrees. And even with these temperature rises where people sort of say, well, this is what we want to reach, even with these changes, we might see major changes in ecosystem structures and functions. We might see species ecological interactions and shifts in species geographical ranges. So meaning certain species might not be able to live where they currently live or live at all, with predominantly negative consequences for biodiversity and ecosystem goods and services. So how might this manifest itself? It might change the availability of freshwater resources, both for humans and animals, right? And they might even increase in some areas, but they might also decrease in other areas. We might see things like ocean acidification and strong effects on marine life. And it more generally might see effects on human health and wealth. And they might come from heat waves. So there's evidence that heat waves might lead to excess death in certain circumstances. You might see a change in the spatial distribution of infectious diseases. So if you think about diseases like malaria or other tropical diseases, they have been basically creeping into non-tropical zones again, because simply the flies or the mosquitoes that transmit malaria can now live in places they couldn't live before. We might see basically more extreme weather events. So if you think about the hurricane season in the US, then there's some people who are concerned that this hurricane season now stays longer and has more severe events. And more generally, it might have effects on productivity, agricultural yields, and then also migration patterns, both of animal species and of humans, right? So pretty grave consequences. So what I want to show you here in this slide is basically a nice paper by Carlton and Yang from 2016, where they try to assess, well, how large are these effects? So what does it matter that temperature changes? So what they do in these graphs is look at a specific location and then look at, effects of temperature changes in this specific location on variables of economic importance. So the very first graph from this paper, this graph J, is basically a graph on gross domestic product per capita. They look at this around the globe, but in each place they basically look over time at variation in temperature. The nice thing of doing that is that these temperature variations are semi-random. So you're looking here more or less at a causal effect, right? And what you can see in all of these graphs, and I will show you some more of these on the next slide, is that there seems to be something like a temperature optimum that we have adapted to. And we have adapted the way that we produce things to this. We have adapted a way of how we live to this. And so, so any deviation from this optimum leads to losses, right? And these, in graph J, these losses are measured by gross domestic product, so GDP, something that you've heard of before. If you go to this right graph K, a very similar relationship can be shown for total income per capita. So this suggests that we are most productive in a certain temperature range, and then we get less productive once we move out of this temperature range, right? And you can do this exercise for many other dependent variables. So for many other things we might be interested in, conventional and unconventional things. So people have looked, for example, at cognitive productivity, and the way they are measuring that is by math test scores. So how well did people do on exams, or how well did people do on a math test? And you can see again that around 22 degrees, we are at our best, and then our performance drops off slightly. You can look at how rude people are on things like Twitter, like profanity in social media, so Twitter or Facebook. So how many swear words do people use? And you can see that people might tend to get a little bit more aggressive once temperatures start rising. You can also look at crime. Here, for example, the incidence of rape in the US, and you can see again that this incidence varies with temperature. So the general picture of this paper, and it's a really nice paper that is very easy to read, is that we have adapted our societies to a specific temperature range, and once we start moving out of this temperature range, we might reach points that are not so optimal, right? So in some, unmitigated climate change will have many adverse effects on future human health, wealth, productivity, and well-being. So the big question, and that's the question we want to get at today a little bit, is, so why do we see so much reluctance, both if we look at an aggregate level, so at a country level, or if we look around in our circle of friends or at our own behavior? Why are people so reluctant to take big steps to mitigate greenhouse gas emissions? I'm not claiming that, nothing is being done about this, right? So both countries and individuals, do something about climate change, but from all how things are looking at the moment, whatever is being done seems not sufficient to really dent this curve of rising temperatures significantly. Well, we're all economists here in this room, right? So, an easy explanation, well, it's costly, right? So cutting emissions is costly. So is it simply too costly? Would it not be worth it doing it? Sure, cutting emissions is quite costly. And if you think about carbon emissions, it's extremely costly in the sense that basically any sort of activity you can think of, driving from A to B, producing stuff, using energy, all of this, produces a certain amount of carbon emissions. So it asks us to do something that is much more fundamental than, other environmental problems. But still, even though these costs are so fundamental, if you look at cost-benefit analysis of this problem, and the first exercise in this direction was by a guy called Stern, or Lord Stern, in the UK. And he was basically doing a cost-benefit test of cutting carbon emissions, and he came out generally as, yes, it would be worth it from an economist's perspective to cut our carbon emissions. So we do other things that pass this cost-benefit test. So why is it so hard to do the same thing for carbon emissions? So what I will argue in the rest of this talk is that climate change obviously is a global cooperation problem. And it's not only a cooperation problem, but it's a cooperation problem that has many unique properties that make it really, really hard to solve. And what unique properties do I have in mind? Well, first of all, and let me introduce a term here, it is a global public good. So global public goods are basically goods, and they're very similar to public goods you might have heard of in your lecture. So public goods are typically goods that have non-excludable and non-rival benefits. So what does this mean in a global perspective? Well, it means that if we reduce climate change, every single person benefits from this effort, no matter whether they have contributed to this effort or not. So to prevent climate change, and that's the public good here, emissions of everyone have to be cut by a significant amount. And the personal costs of cutting these emissions may be very large. So if you think about your own lifestyle, and if you had to use current technology to go from your current carbon emissions to lower emissions, you would have to do something quite dramatic. You would have to change how you eat, how you travel, how you heat your house, how you live, and how you do a lot of other things that you like doing. So cutting your carbon emissions by a large amount is actually quite costly on a personal level. So what the problem is, it has quite large aggregate benefits, right? And I put a little exclamation mark here because I'm talking about aggregate benefits here, right? So you're only contributing a very small amount by cutting your emissions to zero, but this cut basically benefits 7 billion people, right, in aggregate at the moment, plus a lot of future people that will come after you. So these benefits are global, and they are basically extending far off into the future. Your individual benefits from cutting your emissions might be very low, and they might be even lower than the costs. And so if you do simply an individual cost-benefit calculus, you might come out with this idea that, yes, it would be nice to stop climate change, but I don't want to be the person that contributes significantly to this effort. Another problem about this global public good is that, you know, we know public good problems on a national level. There are quite a few public good problems on a national level, like cutting down local pollution, cleaning up our rivers, things like that. And these local public good problems we typically solve by institutions, right? We collect taxes from everybody, we force people to not drive into certain places, and so on and so forth. But these institutions, right, a government that could actually mandate things on a global level, do not exist for climate change. And so we don't have a state that can collect, you know, global taxes, write global laws, and enforce them. And what this all means is that there are tremendous incentives to free rides on the efforts of other individuals or other countries. The second problem, and that one I discussed already a little bit, is that, you know, to do something about climate change now, there are high current costs, but a lot of the benefits from these costs lie in the future. They might not even accrue to the same set of decision makers. Why is that so? Because carbon emissions are basically a stock pollutant. They build up in the atmosphere, they stay there for a very long time. And so whatever we do to carbon emissions now has a very long-lasting effect on climate change in the future. So preventing climate change has long-term benefits that mainly accrue to future generations. So what we would need to do here, if we wanted to solve this problem, we would need to cooperate for the benefit of later generations. And that's hard to do, maybe. So the next problem about all of this is what I call heterogeneous costs and benefits. And what this means is that not all individuals in all countries are affected in the same way by climate change. So who's most adversely affected by all projections? So who would benefit most from preventing climate change? It's basically poor people who can't protect themselves in poor countries. For example, if you look at poor farmers in sub-Saharan countries, they are already affected by climate change, right? So they can't earn their livelihoods at the moment because of changing climate conditions. And that's very bad for them. At the same time, those people who would be most able to influence climate change because they have the highest emissions and they might be most able to adapt their lifestyles are least affected by climate change. Even by the worst projections, as long as it stays in some moderate amount, countries of Northern Europe, for example, will not be so badly affected by climate change. And so if you think about the people who could be doing something about the problem, they are really not the people who are most adversely affected by the problem. And this creates another layer of problems. So first of all, this creates distributional conflicts. Obviously, you know, we do other things to help people in sub-Saharan Africa, but we, you know, some would claim we're not doing enough about this anyway. And now we are basically creating another, you know, way of helping these people, which is, you know, is simply hard, right? And it also creates a lot of difficulties in international collaboration. So if you have followed any of the discussions around the Paris Agreement or the Kyoto Protocol, or generally collaboration on climate change, then different countries make different statements about how responsible they should be for finding a solution. And one term that comes up all the time is past responsibilities versus current emissions, right? So there might be simply difficulties in international collaboration because some countries say, well, those who are most responsible for past carbon emissions should do most about the problem. So that would be industrialized countries in the West. If you look at current emissions, then India, China, and another of the fast-growing economies of the East currently produce most emissions. And we can't basically agree on who should be doing most of the heavy lifting. And finally, there's uncertainty, right? So the way that emissions map into economic damages is still poorly understood. There's a lot of research on that. We understand it better now, but we don't understand it fully. We don't know enough about adaptation, so we don't know enough about what we can basically do to prevent damages. And this is the most worrying part about climate change, there's the possibility of large tail risks. So what's a large tail risk? It's basically a low probability but high impact event. So if you think about the current situation, so this is also a large tail risk, right? Nobody would have expected a pandemic of this size happening suddenly, but here it is, right? And we're ill prepared. So for climate change, there's also a couple of these large tail risks where basically you have low probability events that have high damages, but they're not completely improbable, right? So one of these examples is basically the melting of the poles. So that would lift the sea levels quite a significant amount and would destroy some of the cities built close to coasts. So even if that doesn't happen, it is in the room of probability. But the problem, if you think about uncertainty and if you think about human motivation, is that there's always a tendency to hide behind uncertainty. Because things are uncertain, people might be tempted to say, well, let's find out more before we do something dramatic. And the result of these four tendencies is what some people have called a perfect moral storm. So this is a very nice book by Gardiner from 2011. He's a philosopher talking about climate change. So this is a nice book to read. And then Richard Toll, who's an economist who worked on the IPCC panel for the economics part of the IPCC, called climate change the mother of all externalities. So remember what an externality is. So an externality is basically an effect that happens because in my individual calculus, I'm not paying attention to effects I'm exerting on other people. So if you think about all of this, you could phrase climate change as a cooperation problem. And here I'm giving you a very simple, schematic model of a cooperation problem that has a very strong message. And that's completely simplified just to get you thinking about the problem a little bit. So imagine you have two individuals or two countries, and they have two actions. They either can fully pollute, meaning they don't cut their carbon emissions, or they can mitigate. They can basically, cut down their carbon emissions. And what you see in this table is basically the payoffs they would get out of combinations of strategies they can have. So if both of these people decide to pollute, then they will end up with no benefits, okay? If both of them decide to mitigate, they will end up with positive benefits of 3. So it looks already clear that both of them mitigating should be preferable to both of them polluting. However, there's a little problem, and that's in these other two cells. If one of these individuals decides to deviate individually, right? So if, say, country Y still decides to mitigate, country X still decides to mitigate, but country Y decides to pollute, then country Y would get this nice payoff of 5, while country X would have all the costs of mitigation, but little benefits. So they would get a payoff of -2. And as 5 is better than 3, there's a strong incentive for unilaterally deviating from this mitigate point, right? And this incentive exists for both of these countries. And so in the end, you will end up in a solution where both of them pollute. And some of you might have seen this sort of logic before. So this is what is known as a prisoner's dilemma, which you might have been taught in your introduction to economics classes, right? So in this prisoner's dilemma, even though this is a very simplified model, it has a very strong message. And this is that this nice situation that both of them would like to reach is actually unreachable as an equilibrium, because individually you have a lot of incentives to deviate. So now if you think about the same problem for 7 billion people, you might realize that I as an individual, right, have very strong incentive not to change my lifestyle if I hope that everybody else is changing their lifestyle. And so you end up in the situation where basically nobody changes their lifestyle and we go on, blowing carbon emissions into the atmosphere. So the conclusions from this very simplified game: A, cooperation is very hard to achieve. And the question you might ask yourself is this maybe the reason why we may see so little action about climate change? So the rationale here would be everybody wants to do less than everybody else, ending up in a situation where everybody does too little about climate change. Or alternatively, you could phrase it the following way: no one takes the benefits of others sufficiently into account when deciding about their own mitigation efforts. And I think this is a good moment to pause, right? So you might have wondering now, is really everybody that selfish? Is that a good description of economic decision makers? And, you've basically probably been following these debates about economic decision makers. How selfish are they? What does it mean to optimize a utility function? All of this. And this is where the behavioral economics or experimental economics of cooperation come in. So they basically wonder, is it really true that everybody would act so selfishly in a situation like the one I've described to you? So some questions they try to answer is, so how are individuals actually able to solve such cooperation problems that, are not restricted to climate change only, but happen in a lot of daily life situations, right? So we can't be that bad at solving these kinds of situations. And is it maybe true that, one of these reasons why we can solve them is that we care a little bit about how well other people are doing? So do we maybe have other regarding preferences? So am I not only interested in my own payoff from a game like that, but may I also care about the payoffs that other people might get out of a game that I've described to you? And how strong are these preferences? And then most importantly, and this is where I will end my talk later on, can we find institutions that actually facilitate cooperation? Right? And before we do that, I just want to have this summary slide to you, because I think this is something very important and fundamental to understand about cooperation problems, right? And I depicted 3 different cooperation problems here. One that I call hunting a mammoth, right? And this is a cooperation problem that we are very familiar with in our evolutionary history, right? 10,000 years ago or 15,000 years ago, we were living as bands or tribes of hunters and gatherers in small groups. We repeatedly interacted with the same people. We communicated with them, right? This was just an extended family. So there was a lot of kinship relationships between people in these tribes. So this might have been my nieces and nephews and my brothers and so on and so forth. And we all went on to a hunt for a mammoth. And hunting a mammoth is basically a group effort. And you could wonder, how much effort does every single member of this tribe put in? And what happens if I don't put in enough effort to hunt the mammoth? And I think this is where basically, if you think about the psychology of cooperation, a lot of the mechanisms evolve that can stabilize cooperation in small groups. And this is why we are actually good at solving cooperation problems at small group levels, right? So in small groups, you can communicate, so you can tell people if you're happy with what they're doing or not. You can use reciprocity. So if somebody in a small group is nice to you and you keep on meeting this person again and again and again, then if this person has been nice to you, you can be back nice to this person. And that might stabilize cooperation in a small group. I can sanction people, right? So if somebody violates a group norm, I can start being nasty to this person. So I might kick him out of the tribe in the most extreme version. I might not give him enough food. I might just call him names, right? There are a lot of ways how I could sanction a person. the other way around, right? I can tell stories of valor. If somebody's a really nice hunter, if somebody has been doing good, right? I can basically reward people with these stories. And I can enforce norm compliance. We might have a norm of sharing in this tribe. And if people comply, I'm very nice to them. If they don't comply, I'm not so nice with them. And so we learn to comply with norms. So this is where the psychology of cooperation basically comes from. Now think about the current situation, stopping a pandemic, right? So here we are already in a slightly different setting. We talk about large groups, countries, even several countries, mostly strangers. Many of them you will only meet once. With some of them you will never talk. And still you hope that they might abide by certain rules like social distancing, wearing a mask, staying at home, being sensible. But we seem to understand that all of these things don't work very well only voluntarily. There's a lot of reasonable people out there who would do these things, but there's also some people who are not that reasonable. And so this is why we've come up with institutions, right? So institutions would be settings that help us do, solve cooperation problems. So we can ask for taxes, we can write laws, we have a police. And all of these institutions can help us solve cooperation problems in larger groups, right? Where these psychological mechanisms might not fully work to solve the problem. So now if you think about a problem like climate change, if you think back to the title of the talk, you want to stop climate change. Well, here we're talking about a global population. You try to cooperate with strangers to help other strangers in the future. With a lot of these people, you will never communicate. You're not talking to the people in sub-Saharan Africa that you're trying to help, and you're definitely not talking to the people who will come after you. And there are very few enforceable international institutions. If I, as an individual, behave badly towards the climate, there's very few things that the sub-Saharan farmer can do to me to basically, help me comply with any sort of norm that might be out there. So the very fundamental question that comes out of these three types of cooperation problems is, can this voluntary approach that might work well in this small group tribe setting really work in a situation like climate change where the setting is very different, right? So this is what I'm studying. So I'm an experimental economist, as Joey said at the beginning. So what do experimental economists do? Well, we study fundamentals of economic preferences by letting real people, and that's often students, but not always students, make decisions about real money. And you can do that if or when the lab reopens in Birmingham. You can take part in these studies we do there, right? There's a lab called the Beats Lab, and this Beats Lab is actually a lab where you can take part in studies like that. In these lab experiments, we construct decision environments that mimic an economic decision environment that we are interested in, right? And that might be, in my case, as you will see in a second, a intergenerational cooperation problem, or that might be many other things. And the very important thing about experiments, and that's something that is true for any experiment, whether it's in the social sciences or the natural sciences, what you try to do in an experiment is basically changing one feature at a time, and then randomizing participants to different conditions where the feature is one time A and in another time B, and then you can compare what happens in A, what happens in B, and that gets you very close to a causal interpretation of an effect of this change. So what does basically this feature do to a decision? So what I will do for the rest of this talk, I will talk about a recently published paper of mine. So that was published in Nature Communications. So you see me on the left side, and then the other person is Israel, who's my co-author, who's in Berlin. And what we did in this experiment was to try and find out whether one of these institutions that we know work very well in these small group settings, wanted to find out whether this institution can help us in solving cooperation problems where we try to help future people, right? What's the motivation, right? So this is now going to be the slides I used for, a previous talk on this, so they might be a little bit more technical, but I think you can follow them quite well. So the motivation is, we know a lot about these single generation dilemmas from previous experiments. So in these single generation dilemmas, you have a group of students or people. say you have these three people, they have to solve a cooperation problem, and the benefits of solving this cooperation problem flow back to the same three people, right? And that's the most common way of studying public goods or cooperation problems in laboratory experiments. So what is this a good analog for? Well, maybe preventing local air pollution in a small location. That might be a good analog for this single generation dilemma small group setting. So what we wanted to look at instead is what we call a multi-generation dilemma. So in a multi-generation dilemma, you have the same three people here, the people in red. They have to solve a cooperation problem, but the benefits of solving this cooperation problem exclusively flow to these three people in blue, right? And this is, I think, now that you heard all the introduction, much closer to the problem we try to solve when we think about climate change. So the current generation has to decide how much effort they want to put in to solve a problem that will mainly affect later generations, right? And there are many other examples from environmental economics and beyond, where some of these problems are important, right? Climate change mitigation may be the most prominent one. You could be thinking about biodiversity conservation. So we want to conserve a species. We have some benefit from conserving the species, but the largest benefit flows to all the generations that come after and can be happy that the species is still around. Or you could be thinking about fundamental research. So in fundamental research, you have this problem that often when this fundamental research is being done, you don't see immediate applications, and only 30, 40 years later, people realize how useful this fundamental research is for other things. So what we want to answer in this paper is, what are the difficulties at a behavioral level of providing these multi-generational public goods? And in this paper, we look sort of at a most extreme case. It's the case of disjoint generations. And we look at these additional provision challenges that come out of the fact that, you know, these generations are disjoint. And what we have in mind is basically problems with a long time horizon, like climate change. So first of all, they have a very adverse incentive structure, and that should have become clear now. So the cost of provision accrued to the current generation, all the benefits flow to future generations. And now you have two sorts of free riding incentives. And remember, we were talking about free riding incentives before when we were talking about public goods. You have one free riding incentive within a generation and one between generations. What do I mean by this? So first of all, we might not be sufficiently motivated to help people that come later, right? So that's the between generations free riding incentives. We don't want to have these costs to help those that come later, but then also we might want to help these people coming later, but we don't want to be the individual that does most of the heavy lifting, right? So this is the within generations free riding incentives. So we might want to prevent climate change, but even better if everybody else is preventing climate change, and I can still be happy that these future generations are helped, but I'm not contributing a lot to it. And another problem here is that one of the mechanisms which we know works best in these small group settings, which is direct reciprocity, this cannot happen now in between generations. So what's direct reciprocity? So direct reciprocity is this idea, if you're being nice to me, I will be nice to you. And if you do that in a small group, then small groups can basically find the rhythm of cooperation where they help each other in turns, and then this basically stabilizes cooperation over the long run. But here, because these generations don't interact, the future generation cannot be back nice to the past generation that basically did all the climate change mitigation. Another problem that should have become clear now is that there are temporal restrictions on the institutions you may be able to use. So without overlapping generations, so OLG stands for overlapping generations, most institutions are only available within a generation, but not across generations. So what we do in this paper that you can also find online is we use a lab experiment to investigate cooperation for the benefit of later disjoint generations. So two questions that we try to answer: does voluntary cooperation emerge in these multi-generational dilemmas? And then more importantly, can we think of an institution that can facilitate the voluntary provision of multi-generational public goods? So this is just a little picture to illustrate the problem of institutions in disjoint generations. So this is a séance session, so meaning people who try to talk with the dead, right? And obviously this is not possible unless you're very, you believe in things like that. But most people would believe you can't talk to the dead. And that means future generations cannot talk back to past generations that have already died. They also cannot reward them. They can't do much with them. So it severely limits the mechanisms of institutions that can support cooperation. So communication is not possible in a two-way version where the past talks to the future and the future talks back to the past. And there's also no possibility for explicit punishment or rewards, meaning that later generations cannot punish or reward earlier generations. So what we look at in this paper is an institution that is possible, and that one we call contemporary punishment. So what's contemporary punishment? You could be thinking about, there was this term of flight shaming earlier this year when Greta Thunberg basically said, well, we will shame people into flying less. We are punishing them for their behavior, right? So that's contemporary punishment, right? People are not cooperating. They're still going on planes, but then we tell them we don't like what you do, right? And that's available within a generation, but not across generation. And what's so interesting about punishment is that we know from these single generation small group dilemmas or cooperation problems that it works really well. And why is that so? Because there's two reasons to use this punishment, right? First of all, a strategic reason. You want other group members to cooperate because this benefits yourself. And so you want them to, cooperate for your own behalf. Or negative reciprocity. So other group members have harmed you, and so you want to harm them back. So these motives obviously don't persist when the lack of cooperation only harms future instead of current generations. So you could be wondering whether there's still a moral drive to punish those who have harmed future others. And this is what is called strong reciprocity in biology and also economics. So strong reciprocity means if I observe somebody doing something wrong to a second person, I'm still willing to take a cost to harm the person that has harmed the second person, right? This mechanism we know exists in nature, right, and in other group interactions. The question is whether it's strong enough, right? So would I basically call out every single person that harms somebody who comes in the future? So how do we find out these things in a laboratory experiment? So let me talk to you a little bit about what we did, right? So obviously it's impossible to have a public goods game or a public goods experiment that literally runs across several disjoint generations because we would have to wait for 50 or 100 years. What we do instead is we use a very stylized decision environment. This is something we often do in experimental economics. We break down problems into their fundamental parts and then look at these fundamental parts first. So there's no context, there's no framing. We don't talk about climate change. We don't do any of this. We look very much at the incentive structure only. And this is the incentive structure that we used. So how should you understand this picture? So this is an experiment where we invited 12 people, right? And then we cut these 12 people into 3 different groups: the red group, the blue group, the orange group, and the green group. And this red group gets to play first, right? And what can these people in this red group do? Well, people in this red group have to make a decision. They all get 10 pounds from us, or 10 euros in the case, because we ran this in Germany, right? And so these 10 euros then could be used by these 3 people to either keep them for themselves, or they could pay them in a common pot. And a common pot is painted as this black thing. And if the joint contributions of these 3 people into the common pot are 15 or more, then this blue group of people, which basically symbolizes the next generation, gets to play, right? And if they get to play, then again, they get 10 pounds and they can make the same decision, right? So they can again decide how much of these 10 pounds do they want to keep for themselves and how much do they want to pay this blue pot. And then the money in the blue pot again gets tallied up. If it's 15 or more, the game continues to the orange group, which again get 10 pounds, and so on and so forth, until the final generation is reached, which gets 5 pounds each if the game ends basically thereafter. So this is basically the situation in A. So this is a chain of 4 generations. So in B, we're simply depicting a picture where the second group, the blue group, doesn't reach the threshold, so they stay below 15. And you can see that the game ends immediately, and everybody who comes after basically earns nothing. And this is depicting a situation where later generations are basically harmed by the behavior of earlier generations. So we had this punishment institutions. So in a baseline condition, there was no punishment. In a treatment condition, there was basically punishment available. How did this work? After these 3 people made their decision, I can observe what everybody did, and then I can assign points to them, either 0, 1, or 2 within their own generation, but not across generation. And assigning these punishment points is costly. It costs €1 to assign. So if you simply want to make as much money as you can, then you will have to consider whether you want to do this. And punishment is effective. For each of these points assigned to this other person, he loses €3, right? So I have to pay €1 to create a loss of €3. So this is what is called a standard design of maximum deterrence. So this is a design of which we know that in single generation dilemmas, it typically works very well to stabilize cooperation at high levels. So this is not very interesting. So this is an experiment we ran in Heidelberg, where I was previously based, and then in Hamburg later on. We observed 420 people, and it took around 25 minutes to do this study for each. So let's think very shortly what should happen in this sort of game, right? So imagine you came to this experiment to make as much money as possible. So this would make you a money maximizer. Obviously, if you're this first group, this red group, the most money you can make is by not contributing anything to this black pool, right? You take home 10. To reach this threshold, you would have to give up at least £5 so that this threshold can be reached. So if every run in this experiment was a money maximizer, then the prediction of game theory, or the rational prediction, would be nobody contributes anything. And the subgame perfect Nash equilibrium would be one where basically this first group takes home 10, and then nobody else afterwards makes any money. So this again should remind you of this prisoner's dilemma that I showed you at the very beginning, where I told you that, the simple message of this game is that there's an equilibrium, but that's not optimal in the sense that very few people make some money, but all the other people don't make any money. So there's some efficiency loss from this subgame perfect equilibrium. So there can be alternative equilibria with cooperative outcomes, but for these equilibria to exist, you have to assume 2 things. So first of all, you have to assume that people care about what happens to these later people, right? They have to care about these blue people, these orange people, these green people. So they have to have other regarding or distributional preferences. And they have to be sure that the threshold of 15 can be actually met. So they have to be optimistic about their own group members. Punishment should never happen if everybody's a money maximizer. Why? Because basically it's costly and there's no benefit for me within this group. If you believe that people punish, then it can change the calculus, right? So for non-cooperators, they might be worried that they get punished, and that might be a reason why they contribute to this common pot. And cooperators might contribute more because they might believe it's easier to reach this threshold, because they can believe that these non-cooperators are now incentivized to contribute. Okay, so let me very briefly conclude on what we find in this sort of study. So without punishment, only very few generations can be sustained. So this is a very negative message. It means that these other regarding or distributional preferences are not very strong, even in a task that is about, relatively minor amounts of money, and that is basically still about people who are in the same room with you, right? So this is the graph that just illustrates this result. So in this first generation, we basically start out with 100% of generations sustained. And then already in the step from this first generation to the second generation, you can see that this drops down to 29%, then it drops down to 12%, and this very last generation 4 is simply never reached, right? So this shows that individual motives like altruism or other regarding preferences are simply not strong enough to sustain these generations over multiple periods. So second question, and the main question of the paper is, well, can this punishment institution actually help? And here the message is a little bit more positive. Yes, a few of these more of these future generations can be sustained, but even here we see this breakdown only happening later, right? And this is what this graph basically tells you, right? The black bars are the people who don't have the punishment institution available. The gray bars have the punishment institution available. And you can see, if you go to the second generation, that in this punishment condition, the amount of sustained generations goes up. And that's true for each of these generations. But if we go back to generation 4, then here we are back to basically 18% of future generations that can be sustained. So you can see that this punishment institution helps a little, but it doesn't do enough to basically sustain this game for a long time. One thing that is a little bit more positive to take home from this talk maybe is, it's not true that a lot of people are actually selfish. And this is what you should take from this graph. So what this graph tells you is that you have individual contributions. So remember, people were given an amount from 0 to 10. And this just shows you the distribution, the histogram of these contributions across the no punishment and the punishment condition. And what you can see for this very first generation, so this red generation in the little schematic, is that almost 60% or 70% of people were trying to give exactly 5. So 5 is the amount that is needed to hit the threshold if everybody in the group gives 5. So 66% of people were actually willing to sacrifice, £5 to help these other people who came to the experiment with them, or these later generations in the abstract setting that we're studying, to help them along. So this means that a lot of people are actually generous or altruistic or have distributional preferences. And that's basically these bars over here at 0. You have around 17.5% or 18% of people who basically behave very much in line with what models of economic behavior that assume purely selfish preferences would have predicted. If you go to these later generations, then you can see that in these later generations, the availability of punishment has a more dramatic effect. And what's this more dramatic effect? It basically deters full free riding. So you can see that this light gray bar here is much lower than the dark gray bar. And this indicates that with this punishment institution later on in the game, very few participants are actually trying to basically not contribute at all, probably out of the fear that they might be being punished by their own group members. And this is where the more sustained generations actually come from. So we do a couple of things that probably are not so interesting for you. So the very last thing I want to show you is this observation 4. So observation 4 is basically showing you that this punishment institution is mainly utilized in groups that fail to meet the threshold. And the way I will show that to you is with the help of a little regression model. So for those of you who have already studied econometrics, you should be familiar with this sort of way of displaying results. So what do? We run a regression model in which we want to predict basically whether somebody receives a punishment point or not. Here models 3 and 4 look at all of these generations, generation 1 to 3, and then these are our explanatory variables. So first of all, we want to know what happens if the group reaches the threshold. And this coefficient has a negative sign and it has 3 stars. So this indicates to you that groups that reach the threshold, it is much less likely in these groups that I receive a punishment point. At the same time, if I deviated from the other's average contribution, so if I violated a norm in a sense, then it is much more likely that others in my group are willing to give up some money, some additional money, to reduce my own earnings. So this is basically what the punishment institution does. And people are willing to use this institution against people who violate a norm. This one basically shows you, it includes an interaction term for those of you who know what this is. So this interaction term basically shows you that deviating from this threshold is much less severely punished if the group still makes it, right? So you're basically more being punished for making a group fail meet the threshold than for basically deviating from the average contributions per se. The last interesting thing from this is basically that your absolute contributions do not really matter for how much you're being punished, but it's rather how are you acting relative to the other group members. If you're in a group where nobody basically contributes, then you're being less punished. So let me conclude here with a little conclusion and an outlook. So we started with this question of, can we cooperate to save the climate, right? So what I showed you in this last part of the talk is some current research of mine that uses experiments to talk about this question. This is one way how we can think about this question. So our approach was a lab intergenerational goods game with disjoint generations. We allowed for punishment within a generation, but not across generation. And the 3 main findings from this paper are a little bit sobering if we think about this larger question, right? So the multi-generational structure aggravates cooperation problems that exist anyway. Contemporary punishment, and you can think about this as, you know, shaming or any other form of ostracism or anything that you could use to you know, punish somebody from the current generation, leads to higher sustainability up to a degree. But if we compare this multi-generational problem to what we know from a literature on single generational settings, then we see that this punishment is far less effective if the strategic motive to punish is not there. So what's the take-home messages from this whole talk? First of all, voluntary cooperation is always difficult, right? And this is why we have evolved so many institutions that help us with these problems. So we learn to cooperate as a species within small groups for the sake of our fellow group members in a fairly confined space, right? And this is very distinct from the climate problem. And what this means is that relying on these voluntary approaches of individuals is very demanding in terms of the psychology of cooperation that we've been looking at here. So cooperation for the sake of abstract strangers in the future is much more difficult. And obviously we're looking at a very extreme case here. So if you think about, you know, abstract strangers being your own children, then this task becomes maybe a little bit easier, but still we're psychologically not very well equipped to solve these kinds of problems, because this is not what we have been basically in our, you know, ancestral memory of what we've evolved to be as a human species. So if you think about the experiment that we did, well, shaming your flatmate into becoming a vegan might be, you know, successful, but it's only going to work some of the time. So trying to solve this whole climate change problem bottom up by relying basically on reasonable people doing the right thing seems to be very challenging. So why do we have to rely on this in the first place? Because the other thing is also very challenging. As I was saying in the beginning, we don't have the right institutions that can help us with this problem. So the sobering message of all of this is that, you know, this is simply a very hard problem to solve. And this is probably the take-home message. Okay, so thank you very much, and happy to take your questions if you have any. I just have to have a look at